go through some of the problems from your 102 through 109 homework that you'd marked on the survey. Some of these were problems that we've been talking about in this chapter, and then there are a couple that were kind of a preview to next chapter and some things we're going to be doing there. But the first one I'll go through was problem 102, part C. And this one was the one where they wanted us to make an expression. They talked about the excluded values. We're going to be at -6 and at positive 1/3. So remember our excluded values. In most cases, we're going to be when the denominator could equal 0. So if x is not equal to -6, that means we had to have had a factor of x plus 6 in the denominator. If I have an excluded value of 1/3, well, maybe you said that means I'd have x minus 1/3 as a factor. And technically that would work, that would be okay. Probably a better way of writing it though would be something that doesn't include a fraction. So if we think about this, instead of having a fraction there, maybe a better way of writing it would be to have 3x minus 1. Because if 3x minus 1 were equal to 0, that means x would equal that 1/3 that they said was an excluded value. So as far as the denominator, we'd want something like that. The numerator, you could have put different things up there. Probably the easiest thing is just throw a 1 up there. But the excluded values would be just focusing on those factors in the denominator. The next problem was 103 part B. And this is one of those where we had two rational expressions. And we wanted to subtract them. So we've been doing some of these here lately. And we've talked about whenever I'm subtracting or adding, we want to get common denominators. On this one, the common denominator may not jump out at us though. So probably the first order of business here would be taking that 4x squared plus 5x minus 6 and seeing if we can factor it. So let's try to factor it. So in this case, I'm trying to multiply to get -24x squared. I'm trying to add to get 5x. So we could use 8x and we could use -3x. So as we start factoring, 4x squared and -3x, they both have an x in common, which means I have a 4x here. X times -3 gives me the -3x, and 4x times 2 gives me the 8x. -3 times 2 is -6, so it works out. So another way to write this denominator would be 4x minus 3 and x plus 2. All right, let's work on getting our common denominators down. Well, now that I have it factored, it's easier to see they both had an x plus 2 in common. So I'm going to keep that x plus 2 for sure. And then we also have that factor of 4x minus 3, so I'm going to include that as well. All right, now we start making our adjustments. But before we make our adjustments, something else that you might have noticed was this, that we had 16x minus 12, which I could pull a 4 out of. And if I do that, I'd have 4x minus 3. Well, if I have 4x minus 3 there, this actually is going to make my problem a little bit easier because the 4x minus 3s are going to simplify down to a 1. Which means when I find this common denominator, I don't even need that 4x minus 3. And in fact, I really don't have much that I have to do here because all that I have left in the first fraction is the 4 in the numerator. All I have left in the second fraction is the 3, and I already had common denominators. So I end up here with 4 minus 3 or 1 over x plus 2. So sometimes we had a problem like this the other day, but sometimes if you look at factoring not just the denominator, but also factor in the numerator, we may be able to make things a little bit easier on ourselves. And this is one of those cases. All right, the next problem I want to go through, this is really more of a preview for next chapter. Actually, I thought there was another. All right, sorry. So this is kind of a preview of some things we'll do in the next chapter. So this had a couple things going on. It had an absolute value, but it also was an inequality, in this case greater than or equal to. What we'll start talking about is sometimes with inequalities, a better way to attack it is to think of this equation or this situation as an equation. So we know how to deal with absolute values if it's an equation because, actually, I didn't do a very good job of reading this question. If we look at the absolute value of 5x plus 8, if it's greater than or equal to -4, well, what really happens is it doesn't matter what we put in for x. So we don't really even need to jump to an algebraic method here because we know as soon as I take an absolute value, it's automatically going to be greater than any negative value. So in this case, we actually can just say that we have all real numbers. So I didn't even look at the question closely enough there. So in this case, since we had that greater than or equal to, we didn't even have to do any algebraic steps. Again, as we start looking at these type of problems next chapter, we'll have some algebraic ways of doing it as well. The next one we do have to kind of attack differently. This one they want us to do x squared plus x minus 20, that's less than or equal to 0. Well, this one I do probably want to start out by creating an equation, because we know how to deal with this. So in this one, we try to factor by multiplying to get -20, adding to get 1. So I'm going to have x plus 5 and x minus 4. So it means if it were an equation, we've got these two values. X is equal to -5, x is equal to 4. But it's not an equation. It's an inequality. That doesn't mean these two values are useless for us, though. What we'll start talking about in the next chapter is what the book refers to as boundary points. And we basically have come up with two boundary points. We've come up with -5, and we've come up with +4. Well, that really creates three different areas that we're going to look at. We've got values that are less than -5. We've got values that are between -5 and +4. And we have values that are greater than +4. We want to know of those three different areas, which areas would create a situation where x squared plus x minus 20 is less than 0. So to find out that answer, I'm going to choose a value, first of all, that's less than -5. So I can choose any random value. Let's say I said x is -6. And I plug that into my equation. -6 squared would be 36. Plus -6. And then minus 20. So in that case, I've got 30 minus 20, or I have 10. So the question is that less than 0? Obviously, it's not less than 0. So that means these values did not work. Then I go to a value that's in between -5 and 4. So probably the easiest one to use there would be 0. Well, if I plug in 0, I'm going to have 0 plus 0 minus 20. And the question is that less than 0? -20 is less than 0, so we say, yeah, that does work. So the values in between, they do work. then I might check the values that are larger than 4. So let's put in a positive 6 this time. So 6 squared is 36, plus 6 minus 20. So 42 minus 20 is 22. And again, I find out that doesn't work because 22 is not less than 0. So I've got this situation. I've got the situation where the values in between -5 and 4 are going to be the ones that make this inequality correct. So here's my answer. I'm going to write it kind of like we did back when we did domains, ranges, things of that sort. I'm going to start with my low value of -5. It's less than x, which is less than 4. And so that would be my answer for 104B there. Again, that's kind of a preview for what we're going to do in chapter 4. We're going to start talking a little bit about boundary points and inequalities, things of that sort. All right, the last couple that you had marked on the survey, one of them was part B on 107. Part B on 107, we've got a situation where we're taking these two and we're doing some division. So the nice thing about this one was it was already factored out for us. So really our main thing we're going to have to take care of is make it into a multiplication problem. Because right now it's division. So notice I'm doing the reciprocal of the second fraction. All right, from there we're playing our matching game, looking for simplifying terms. So we got n plus 11s. We've got 4m minus 3s. We've got m minus 3s. And we actually have everything. So it turns out that this one is going to simplify down to just a 1. Well, could we have gotten there faster? Well, in this one, yeah, we actually could have, because if I'm looking at a fraction and I notice that I have, in this case, m minus 3 over itself, I could have actually done that canceling at that point. Over here, we had m minus 3s. I could have done the same thing. So basically what we were left with was m plus 11 over 2m plus 5 divided by m plus 11 over 2m plus 5. So basically I was taking one fraction, dividing by itself, and that's why we get 1 for our answer. Okay, the last one. Now the last one was a multiplication problem. It was not factored though. So we had to do some factoring to start. On the first one, when we factored that one, again, generic rectangles are fine if you want to attack it that way. But let's see what we can factor this into. Let's see, we need, looks like we're going to have 4 and 3. So we have this because we get 8p and then minus 3p. All right, so we got that one. And if we factor in the denominator, this time we need 3, so it looks like negative. Can we factor that one? So we need negative 3 and negative 1. Okay, so we have those two factors. Then over here we've got we got to multiply to get negative 9, add to get 8. And lastly, over here, we've got to factor this one. So this one looks like if we do this, we're going to have 12p when we multiply, minus 2p, so 10p, so we're in good shape. All right, so again, that's usually the hardest part. All right, now we got our factors, so we can start doing our simplifying. And so we've got p plus 9 over 3p minus 2. All right, so those were the ones that were marked the most from the homework. So hopefully that helps out some with some of your questions that you have.